Welcome to today's ICAD Digital class. Today we're exploring a fascinating concept from chemistry called Hess's Law. Dear students, consider the process of baking a cake where various ingredients undergo chemical reactions to form the final product. Reflect on how the total amount of heat released or absorbed during the baking process can be determined by analyzing individual steps. How can we apply this idea to understand the concept of total enthalpy change in a chemical reaction? We have a law to answer this question, the Hess's Law. It states that the total enthalpy change for a chemical reaction is independent of the pathway taken to achieve the final products. In simpler terms, it means that regardless of the route a reaction takes, the total heat change remains constant. Think of the cake-making process as a series of chemical reactions, from mixing the ingredients to baking the batter and cooling the cake. Each step involves specific heat changes contributing to the overall enthalpy change of the process. By applying Hess's law, we can break down the baking process into individual steps and analyze the heat changes associated with each. Finally, we can find the total enthalpy change by summing these individual enthalpy changes. But the question that pops in one's mind is, why should I study Hess's law? Let's take a real-life application. Food preservation through canning. In the canning process, food is heated in sealed containers to destroy microorganisms and enzymes, extending its shelf life. Hess's law allows engineers to calculate the total heat input required for the heating and cooling steps involved in canning, optimizing the process to ensure food safety while preserving its quality, flavor, and nutritional content. In essence, Hess's law not only helps us appreciate the chemistry behind everyday processes like baking, but also plays a pivotal role in ensuring food safety and preservation. ICAD School of Learning, where learning is simplified.